Hi everyone, this video is specifically about exponent practice. And before we get into radicals and exponents again, I want to go over some properties of exponents that you learned in Algebra 1. And I'm just going to put these up here in the corner of these notes. So these are the most popular ones that you learned in Algebra 1, and they're going to come in very handy for Algebra 2. So let's say you had some base x raised to the a power, and you multiply it by something x raised to the b power. When you multiply and you have the same base, you need to add your exponents. So that would be, that should be x raised to the a plus b. Now, the other way, if you have x raised to the a power divided by x to the b power, then when you divide and you have the same base, you're going to subtract the exponents. So that'll be a minus b. The third one is if you have x raised to a power and then you raise that entire thing to another power b, then you multiply these. So this would be x raised to the a times b. And then the last one is if you have x raised to a negative power. And this one happens a lot, and we're not allowed to answer with negative exponents. So this is really x to the negative a over 1. If you were to write that as a fraction, everything, all whole numbers are over 1. So to write this with a positive exponent, you move the entire term down to the denominator. When you do that, this exponent turns positive. So whenever we have negative exponent answers, we need to move our term down to the denominator. And this is the one that nobody seems to like, so we'll probably practice that one a lot so that we get it right all the time. So this is from Algebra 1. Now let's go over to Algebra 2 and talk about this. We did this a little bit in the last video. I just want to review it again. So if we're going from a rational expression to an exponent, that would be something like this: x to the m over n. Okay, notice that this is different than this Algebra 1 rule over here. See how this has x here on the top and the bottom? This just has one x as the base, and we're raising it to a fraction. So when we do that, we can write this as a radical. Okay, so this should be rational to radical form. So this is going to be the nth root of x to the m. Please make sure that you memorize that. They will not give us that on the SOL formula sheet. Now, if I want to go from a radical form to a rational form, then that would be the opposite. If you have the nth root of x to the m, then that's going to be equal to x to the m over n. Okay? Okay, so let's actually try rewriting the practice problems. If you have radical form here, we want to write it in exponent form. So that means we're going to have x raised to some fraction. There's going to be something in the top and something in the bottom. So the number that's in the index always goes in the bottom of your fraction. So if you can remember that part, then everything else will work out. So this will be a 5 in the top. So x to the 5/3 is the same as the third root of x to the 5th. For this one, now this one's a little trickier. That 2 really is raised to the first power. So we're going to break this up into multiple radicals. This is going to be the same as 2 to the 1/5 times n to the 4/5. We had to break that one up because there wasn't parentheses around this 2n. So that 2 really has an exponent of 1. So 2 to the 1/5, n to the 4/5. Same with number 3, and these are multiplied. So 3 to the first right here. The index on a square root is really a 2. So this is 3 to the 1/2, x to the 3/2, y to the 6/2. Now, we could simplify 6 over 2. That's definitely something that's going to be a whole number, so I could rewrite that 3 to the 1/2, x to the 3/2, y to the 3rd. You could put 3 over 1, y to the 3rd is the same as that. So that's how we rewrite from radical form to exponent form. So let's try it again. Now we're going to go from exponent to radical form. So now if I'm writing in radical form, I need to start with a radical. I need to have a radical in my answer. So the number in the bottom goes in the check mark. And then the 2x has parentheses around it, so I'm going to keep those parentheses, and we raise it to the 3rd power. For this one, you have 2 separate ones, but notice they both have a 5 in the bottom, so we could write it as one radical, put the 5 in the check mark, and then this is going to be x to the 4th, y to the 7th. For number 6, we have both of these to the 3rd power. So if we wanted to write 2 separate radicals, we could to start with. And then you could put them all in one radical at the very end. So this would be 3x. I put the 3 in the check mark. So the 2 is going to go right there. And then the cube root of 4y. I put this 3 in the check mark, so I'm going to raise this to the 4th.
Now, since these both have the same radical, the same index, we can combine it to be 3x squared times 4y to the 4th. We'll be learning how to simplify this in a couple more videos, but for now, just rewriting it in radical form, we got it. Goal is achieved. Okay, I hope these examples helped. Try some of your practice problems and feel free to ask me lots of questions. Thanks.